Now we are discussing ultrasonics, ultra, infra, sonic, violet. When it comes to light, we know Vibgayar, violet, red. Before red, infrared. Okay. The frequency is like this. The frequency before red, infrared. Frequencies after violet, ultraviolet. When it comes to sound wave, human beings can hear the sounds between 20 Hz and 20 kilohertz. Before the 20 Hz, we may have the sound. Example, 5 Hz sound. 5 Hz sound. But you might not be able to detect with your or perceive with your ears. That chair might be giving the sound, but we might not know it. Electrons are revoluting completely, but we might not able to perceive that. Earth is revolving continuously, that is giving sound, but we might not able to perceive. Dogs can perceive compared to human being. So we are discussing the human audible range between 20 Hz and 20 kHz. So if there is a sound signal before 20 Hz, such type of sound signal we are calling as infrasonic. Sonic means the range in which we are listening. Because 5 Hz is not the audible range, it is before, we are calling as infrasonics. If the sound signal is beyond 20 kHz, then it is called as ultrasonics. Means we are not able to hear that sound. Example, 1 MHz sound. We are not able to hear. We are not talking about the voltage or amplitude of the sound. If you are taking a loudspeaker and if you are keeping a much sound, that will not increase the frequency. Remember my point. If you are taking big loudspeakers, that does not mean it is ultrasonic sound. If you are taking a loudspeaker which will give the sound to the entire Parvatipuram, that does not mean it is an ultrasonic wave. Here we are referring to the frequency. Remember this point. Frequency. Signal frequency. If the signal frequency, generally whatever the voice we are speaking, that will be in the range of maximum 10 kHz. Compare it to male voice, female voice frequency is higher. Compare it to female voice, children, small children voice frequency is much more higher. Compare it to human voice, instrument frequency is much more higher, like drums, guitar. We cannot, our vocal cords are not able to produce that much frequency, but they will produce. Okay. So before 10 kHz only, generally whenever we are working with the modulation, when we are sending the signal through mobile or everything, generally we try to replicate the human voice. After 10 kHz, generally instrument sounds only, which our vocal cords find difficult to produce. But beyond 20 kHz, that kind of sound our ears are not able to perceive. Remember, I am saying not able to perceive. That does not mean that sound waves will damage your ears. Clearly, I am distinguishing. There might be 30 kHz sound wave. It might reach your ear. If the amplitude is low, voltage is low, that signal might not damage your ear, but you are not able to hear anything because your ears can perceive the sound between 20 Hz and 20 kHz. But we use these ultrasonics in the medical imaging. Example, whenever you go to doctor saying that food poison happened, I am feeling some difficulty in the stomach, they use ultrasonics. Okay, they will not do X-ray for the stomach. Whenever you go to hospital, you ask. Whenever they want to test something, the food pipe particularly, they will not directly send, okay, go to X-ray room, they will not send. X-rays are harmful. When they are operating the X-rays, especially to some regions like brain, the regions which are very much sensitive, X-rays will affect. Bones, it is fine. Example, if you want to know some fracture in somewhere, okay, X-rays might detect definitely initial stages fracture, that is fine. So, without any harm compared to X-ray, if we want to know some example, some problem in the stomach, maybe food poisoning, at that time we might use the ultrasonics. Or even by using the ultrasonics, even doctors also, they try to understand the child baby movements in the mother. Similar kind of things without any harmful for the small baby. That can be done by using ultrasonics. X-rays are harmful to us. So that's why we are moving to the ultrasonics. But not only that, if there is a defect in this duster, if this is a metallic duster, entire metal is there, but inside some portion is vacant is there. You went to some shop, they told to make some gold ornament, but later you got the doubt whether completely they used gold or not. Like Hierarchus, he wanted to know whether my throne is completely gold or not. Whether the worker completely he made it with gold or he mixed anything. Then Syracuse called Archimedes. And Archimedes, after several experiments, he suddenly sat down in the bathtub. Immediately idea entered to his mind. And he ran saying that Eureka, Eureka means I found. What he found? When a person sits in a bathtub, water level will increase. Similarly, if we keep the gold in the water level will increase. According to the density of the metal, the water level will change. That's how Archimedes proved there is some other metal mixed in your throne. That's how Archimedes tested whether in this throne gold is there without breaking. We can break and we can test. But without breaking that throne of the king, he tested saying that this is not pure gold. Similarly, by using the ultrasonic, we can find there is a defect in it. Outside it may look well, but inside there is a defect. That is called as flaw detection. We can do the flaw detection by using ultrasonic. We will send the wave. If there is no flaw, the wave will go through entire thing. If there is a flaw, the wave will reflect from that point, indicating that there is a flaw in this object. That's why we use it for industrial machining and welding and wire drawing, for all this in soldering also. We use the ultrasonics. Ultra means beyond 20 kHz. Sonics, this is audible range is 20 Hz to 20 kHz, because this is beyond 20 kHz we are saying this is an ultrasonic wave.